Hey, hello everyone. Are you able to hear me? Can you all please confirm? I'm going to mute you all from my side just to ensure that there is no background noise. Perfect, perfect. Thank you all for joining in. I really appreciate that you're trying to upskill yourself even at this time. Is my voice okay? Is it not audible? A few of y'all are saying that my voice is not audible. I usually speak at the peak of my voice. So if my voice is not audible, that means something is wrong with your system or with your ears. Okay. All right. Let us get started. Someone is saying your name is Jagadish Kumar, right? Who is Jagadish Narendra? Narendra? I'm not sure. Okay. So that means I need to introduce myself. Otherwise, you'll assume that I'm someone else. So let me quickly introduce. I'll not take a lot of time because there is a lot of information that I need to cover given that we have an hour approximately. Okay. IAP already has some issues, so I'm not sure. Uh, Everyone else is able to hear, so I'll get started. This is me. I have overall 14 plus years of experience. After 1 month from now, I can claim that I have 15 years experience. I would have completed 15 years. I'm an alumnus of ISB and IIT. I'm a digital transformation expert and industrial revolution 4.0 implementer. 70% of our time we spend on consulting, wherein we do projects for various customers, and another 30% of the time we deliver trainings. Okay. 40 plus big data, data analytics, and artificial intelligence projects is what I've accomplished until now. Let me also keep the chat window open. Okay. And then I have trained 4,000 plus professionals across the globe. These are the bunch of certifications which I have, ranging from PMP, ACP to RMP. I've done my Agile project management from APMG UK. I've done my Lean Six Sigma Green, Black, and Master Black Belt from RAB QSA, Quality Society of Australasia. I'm Tableau certified, ITIL certified. I've done my Scrum certifications. I'm a certified auditor, right? Such a boring profile. And then I've done TCS ION ProCert just to test the waters on how the certification looks like. But it was fairly simple, and except for TCS, no other training institute values this. Why are you so interested? I'm from IIT Hyderabad, Somit. I've seen your question, but I think that is more interesting for you than the session, right? So let's focus, guys. Don't let us not get sidetracked. These are the various companies that I've worked with: HSBC, Indian Tobacco Corporation, Infosys, and Deloitte. Deloitte was the last company with which I was employed as an employee. Alongside that, I'm a director on these two companies. Alongside that, I happen to be a chief data scientist on these four companies, and I happen to be a visiting faculty of Watson Business School. Right? This is in short about my profile. And I can also quickly open my LinkedIn profile and showcase a few more interesting things. People who are interested in connecting with me on LinkedIn, please do so. There are a lot of senior profiles which are available on my profile. So it might be a good opportunity for you all to network. So let me quickly post that on the chat window. There you go. Just in case you want to know anything new, anything more. And then I also wish to show you the posts and activities. Recently, I've posted binge watching. You might want to look at this video of binge watching, and then it really makes sense. And with respect to posts, we have a lot of videos. Okay, and this is one video which I used to play for you guys. Just have a look at this. This is a project that we have done for a toll booth. If a vehicle crosses a toll booth, we would automatically determine which vehicle is that. For example, if the vehicle moves in this bounding box, it automatically tags on what that vehicle is. And it actually counts, right? For example, this is a two-wheeler kind of, and this is a car, this is an auto, this is a bike, right? In that way, it counts basically. This is a project which one of our participant has done alongside our team of data scientists. So we give our students an opportunity to work on such live projects. It's there on my LinkedIn profile. Any day you can go, just have a look. We've also done a project for Paradise. It's Paradise chatbot, Paradise Biryani, right? That's one of the mouth-watering food that we have in Hyderabad. Right here we have that. And our past participants get involved in all of these projects, friends. When we train, we also give our students an opportunity to work on live projects. Okay, and then behavioral analytics, one of our participant has done this. It actually puts a bounding box and determines the gender. And it also determines with certain probability, okay? And it determines whether a person is sleepy or is a person neutral or is a person kind of happy, so on and so forth, right? This, we are trying to bring it into our learning management system called AI Sprite. And a lot of those additional things. And one more thing, which I do not wish to miss out, is the chat, the robot that we have built. Let me play that. Here we go. Hello everyone, I am Kate. A warm Hi Enoch, I am Winnie. You look so excited to see me, so I thought I can answer some of your questions. Data science. Data science is a multidisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insight from structured and unstructured data. Hi Winnie. I am listening. Wish hello to everyone. So this is how our past participants got involved in building the robot as well. We firmly believe that we need to give our past participants an opportunity to work on live projects. And this COVID-19, which I have done now, a few of our participants got involved. And that is this particular project. Okay, apart from that, we also have domain analytics trainings because industry is expecting one, our data scientists or AI experts to also have industry domain analytics knowledge. For example, if there is someone with MBA finance or works in a bank or insurance or any of the financial sector, any of the financial sector companies, then financial analytics makes more sense. If a person is working in HR analytics, marketing analytics for those who work in marketing, supply chain analytics for those who work in supply chain, so on and so forth. We have 56 plus domain analytics programs in total, right? Having said that, we, in collaboration with international universities, we have launched our India's first full stack data scientist program. It's a 1-year program, basically. All of our programs have international accreditations ranging from City and Guilds UK, which is an establishment which has 150 plus years of history. Okay, and then it is backed by Queen of England. It is so prestigious that people who do not graduate, who do not undergo the graduation, go for City and Guilds accredited training program, and they become job employable. We also are backed by University Technology Malaysia, which is one of the top 5 universities in Malaysia, right? And we have TUV SUD accreditation, which is a German-based certification body. These are the sample certificates which one would receive from City and Guilds or from UTM Malaysia, so on and so forth. Welcome to the webinar on COVID-19 forecasting. Here is our agenda: recession and its impact, step-by-step plan to transition into AI and data science, finally the forecasting strategy, followed by the hands-on. Okay, things are looking very alarming. Millions of Americans could lose jobs. Indian Monetary Federation chief has just declared 2 days back that we are into global recession. That means a lot of people are here to lose job. Don't be scared. Losing job is common as part of economic turmoil. Stock markets are plunging downwards south, right? In Malaysia, US, everywhere else. More than half of American jobs are at risk. The recession is going to be bad, really bad. Have no doubt about that. That is what Washington Post says. People who are laid back, who do not want to upskill themselves, trust me, friends, tough days are ahead of you. Hong Kong, UK, Germany, Italy, China, you name it. These countries are facing real problem. Turkey, Argentina, Iran, Mexico, Brazil, they are facing a lot of stress on the economies. Japan is already into recession. South Africa is into recession. Globally, we are into recession. That's a very sad thing. Very sad thing for us, right? And US will inevitably fall into recession. A lot of COVID-19 cases, a lot of businesses shut down. Things are looking very bad. Okay, and here, what are the two things that usually drive economies? The two things that usually drive economies are stock market and oil, majorly. But both of these across the globe are taking a severe hit. One is because of COVID-19, another is because of Russia and Middle East tug of war in terms of reducing the oil prices. So things are not looking fancy at all. And people say that things would be really bad. It would be bad or more bad in comparison to the 2008 recession which the world has seen. What to do and how to cope up? One obvious thing is get yourself upskilled on recession-proof job. That's what AI, that is what data science is all about. These are truly recession-proof. AI, as such, people are saying that AI would destroy jobs. No doubt. AI would destroy the jobs of those people who do not want to upskill. According to World Economic Forum, 75 million jobs will be displaced by 2020. And about 133 million jobs will be generated in the due course. That means a delta of 58 million new jobs would be created by AI by 2022. McKinsey says 14% of the workforce will be in dire need to switch occupations in the next 10 to 15 years. And 38% of the current jobs will easily be automated. 38% of the jobs. And how will these be automated? Using AI applications. What does that mean? That means we need AI professionals. We need data science experts to build such automated systems. Hence, I clearly wish to tell you that data science or any data related profession would be certainly recession proof. Organizations will wish to save a lot through automation, and data scientists and AI experts would exactly do that. AI would add $13 trillion to the global economy by 2030. That's a huge thing. Recession and AI jobs, this is the next generation. This is going to churn out a lot of next generation professionals. Step by step approach. First thing, if you want to transition into AI or data science, learn from real data scientists, not theoretical data scientists. What people do is they go get trained with some training institute. Since there is a lot of demand, they start their own trainings without having any knowledge on how to do projects in real world. Ask them questions such as, hey, how do you deploy a model in production? What do you mean by code modularity? What do you mean by building your model at scale? How do you deploy a model in on cloud? Ask them such questions. They will be dumbstruck, right? They will not be able to answer. Who? When I say they, theoretical data scientists, don't get fooled by them. Next, learn on practical use cases and projects. We at 360 Digit MG believe that we have to include practical use cases in our training. I've just demonstrated a few of those, right? Projects that we have done. And what we do is, as part of INNODATATICS, which is rated as the 20 most promising data analytics solution providers for 2018. As part of INNODATATICS, we do a lot of projects. It ranges from life sciences healthcare, that is building cancer prediction models, to predicting on loan defaulters. We are also there in aviation, automation, bunch of these, right? If you want to learn more, you just click on the industry of your interest, click on the use case, and then you'll be able to understand problem statement, challenges, solutions, and the impact that we have left on the organizations. Coca-Cola, TrueJet, there are a bunch of companies that we have. These kind of projects, we bring it into our mainstream training. Earn certificate from reputed universities, right? We have a lot of reputed universities backing us. And if our students clear the exam, we award them the certificate. Get those, not from any ABCD training institute, right? It doesn't carry any value as such. Learn the most in-demand tools and techniques. Every 3 months, our team of researchers update the curriculum to bring the best to you guys, right? Learn these continually practice, practice, and practice, right? If you assume that you would watch YouTube videos, if you assume that you're going to learn Google, and if you assume that you will become good data scientist, that is a myth. Okay. It's like swimming, friends. If you watch YouTube videos and if you go Google for books and then read books, and then if you jump into swimming pool, you will not be able to swim. Practice is needed. You need to constantly stay in touch with the best to be able to learn and practice, right? So that's very, very important. And sure. So in the next session, we are going to discuss on how to predict COVID-19 cases using X-ray images. And we will be learning deep learning in the next webinar. And in this webinar, we are going to learn forecasting. Let's get there. Here is a forecasting strategy. We need to first define our goal. Okay, we need to clearly define our goal. Say our goal is to forecast, right? Forecast number of COVID-19 cases for March 31st. Today is March 31st. Today, end of business. How many cases would be there? What I've done is I've gone to internet, done a secondary research, and I've downloaded data. And let me show you the downloaded data. I've downloaded from WHO, World Health Organization. Okay, I downloaded a lot of data on how many confirmed cases, how many deaths, how many people got treated. We have data from Jan 22nd until yesterday, 30th March. I've taken this data. Every day data was getting updated. Good. And I did not have all these friends. We only are given this data. You'll not have anything else which I've just created. Okay. So you collected the data. How many data points from 22nd Jan until March 30th? I've taken the data. How many data points? Let me count. We have 69 data points. 69 data points. The third step is explore and visualize the series. Friends, usually you spend good 8 to 9 hours doing the project, right? 8 to 9 hours of the speed at which I work is what I'm demonstrating to you guys. Okay. I usually work at lightning speed. And I'm not boasting, that's a fact, but anyways. So you go insert. For me, it has taken good 6 to 7 hours to figure out what is the best, right? So you have this confirmed cases. Look at that. It's growing exponentially. Exponentially. There is no linear trend. It's exponential. Okay. So I understand that there is an exponential pattern going on here. That's one thing. Then you need to pre-process the data. How do you pre-process the data? Okay, you need to decide upon what additional variables you need to add. For example, yep. So what I have done is, let me add one more. Yeah, I've taken a lot of variables. Now I'll not go about why did I do that in a detailed way, but at a high level, I would tell you. I've included lag. Lag means maybe the previous day cases has a correlation with the current day. Previous day it was 555, current it is so much. That means the next day, when I move to the next day, this becomes the previous day. This is the current day. When I move to the next day, this becomes the previous day and this is the current day. When I move to the next day, this becomes the previous and this the current day. So on and so forth. That's called as lag. And this is called as, in forecasting terms, one step lag. Guys, forecasting session in our training would last for probably 6 hours or so. I'm trying to condense this into maybe 30 minutes or less than that. You need not worry about finer nuances. If you can get a high level picture on what is forecasting, how did they build this model, is it accurate or not? That's good enough for you guys, okay? And if you want to capture trend, that means say COVID-19 cases were like that, growing linearly. We know for a fact that it's growing like this, which is called as exponential, but assume it was linear. If it were linear, you include t, time variable. T equal to 1, 2, 3, 4, in that way you have 69. If at all, say, your data was appearing like this, or your data was appearing like that, then you add t square, which is called as quadratic trend. And when you see one bend, there is only one bend, right? One bend. Then you have t and t square. You include t and t square for quadratic. Suppose the trend was like this. It would eventually come down to a number of cases, but assume the trend was like that. You have two bends. If you have two bends, then you have to include t, t square and t cube also, because there are two bends. If you have one bend, you use t and t square. Hence, when you have one bend, it is called as polynomial with 2 degrees, and polynomial with 2 degrees is also given another name called as quadratic. If you have two bends like this, it is called as polynomial with 3 degrees. Question to you all, if I have n bends, then it will be called as polynomial with, if I have n bends, then what do I draw? Polynomial with how many degrees? Come on, friends, I'm helping you guys become analytical now. I request you all to support. Absolutely, n plus 1, not n minus 1. Dhananjay, degrees of freedom is different. Polynomial with n plus 1 degrees. Wonderful, guys. Wonderful. I really appreciate, we have a lot of people, Vikas, Jay, Dhananjay, Adarsh, Sarath, Prasanna, Ayan, Vikas, someone with Redmi, Payal, all of you have responded. Great. I really appreciate that. Okay, now you add this. Then when you have exponential trend, sorry, exponential trend would look like this. It starts from almost there and then it goes like that. Exponential. When you have exponential trend, you include log of your variable. You are interested in number of confirmed cases, forecasting the number of confirmed cases. So you take log of that. That will help you capture exponential trend. And then when it comes to any forecasting technique, you primarily will try to forecast the trend, or you want to capture the trend and also seasonality. And here you have daily data. Let me tell you this, that if you have monthly data, right? That is, if you have data for Jan, how many cases, Feb, number of cases, March, so on and so forth, then we need to have minimum 1 year data to be able to capture seasonality. Why? Within 1 year, you'll have summer season, you'll have winter season, and you'll have rainy season within 1 year. Maybe in certain seasons, the number of cases are less. In certain seasons, the number of cases are more. We really don't know. But to determine that, you need to have at least 1 year data, which we don't have now. Okay, which we don't have. If you have monthly data, you should have generated, or you should have created dummy variables such as D1, D2, D3 in that way, all the way until D12. 12 months, so 12 dummy variables. If the first entry was, say, related to Jan, then you'll put a 1 here and 0 in all the other places. If it's Feb, you put a 1 for D2 and 0 in all the other places. That is how we create dummy variables, so on and so forth. If you have quarterly data, right? If you have quarterly data, you'll have 4 quarters in 1 year. Okay, you'll have 4 quarters in 1 year. And you know for a fact that 1 year captures all the seasons. Hence, if you have quarterly data, you have to create 4 dummy variables, D1, D2, D3, and D4. If you have data for quarter 1, you put a 1 and 0 elsewhere. For quarter 2, you put a 1 and 0 elsewhere. That's how you create dummy variables. Then Q3 and Q4. However, the way we see, COVID-19 has daily seasonality. Daily it is changing rapidly. And when you have daily data, you cannot say that 365 days is equal to 1 year. So I would generate how many dummy variables? D1, D2, D3, D4, D5 in that way, 365 dummy variables. No. This means you would make your model extremely complex. Hence, what people usually do is they capture sine and cos. In some sense, the daily seasonality is captured by sine theta and cos theta. Trigonometry, friends. You do sine of 2 pi t divided by 365.25. Why? Because every 4 years you have a leap year, 1 additional day. In 4 years, if you divide that 1 day, it will be 0.25. So that is what we have done. We have taken sine 2 pi t, t is time variable, divided by 365.25. And for cos also, we have done exactly the same. Cos 2 pi t, d2 is t, by 365.25. Okay. And we have built these two. Now these two will capture the daily seasonality, sine theta and cos theta. That means overall seasonality for the entire duration is captured in these two variables. That captures daily seasonality. I'm not sure who is read me. You change your name, please, guys. Okay. And then what we need to do is once we pre-process the data, that means prepare the data, we need to partition the data into training and test. And then we are going to apply a lot of forecasting models on the training data and we test it on the test data. Once we test on the test data, we will be capturing mean absolute percentage error, which is one of the error measures. And then say we build different models such as linear model, quadratic model, exponential model, okay, trend plus seasonality models. Say you build all of these variety of models. For each of the model, you capture mean absolute percentage error, and that model which gives you the least error is the best model. And then you deploy your model in production. You implement your forecasting system, right? So we are at this step now. Let's resort to R and let's do this. Okay, as I've told you, I would not be able to get into the minute of the depth. Captures daily seasonality, yes, and not get it now. So as I've told you, Mr. Abhi and someone using Redmi, right? Let me tell you guys that 8 hours of training, we are trying to compress into 30 minutes. Right? That's the reason why I cannot get into the minute of the details, Abhi. Or I'm not sure what your name is. You're using Redmi. Okay. Right? That's the reason. You understand that sine and cos captures what? It captures seasonality. What does it capture? Seasonality. That's it. That's more than sufficient for the time being. Okay. So I'm going to load this particular library or package. And then read underscore Excel, file or choose. It throws a pop-up window. And then I'm going to go and choose a file. Right. And in this file, we have all of this data which we have pre-processed. 69 is a very, very small, tiny data set. Given that data set, right, it is very difficult to really analyze and make out good insights or build a good forecasting model. Despite that, we have done the best to bring the error percentage down to 2%. Let's see. When I say attach COVID, attach this data set, I can refer to the column names directly. If I do not attach, if I were to refer to any of these columns, I have to say COVID dollar confirmed if I want to refer to this column. If I want to refer to this T, I have to say COVID dollar T in this way. Let me quickly write it for those of you who are pretty new. So if I were to refer to this, I have to say COVID dollar T, right? For example, COVID, that's a dataset name, dollar T. That will refer to this column. But if I attach, even if you say T, it will give result. if I would not have run this attach, it would have thrown me error if I say refer to this column T. Now what am I doing? I'm splitting the data into training and test. When it comes to forecasting data, remember one thing, we do not randomly split the data into training or test. Okay, we do not randomly split the data into training or test. Okay, we sequentially split the data. So I'm sequentially taking rows number one, rows 1 to 56 and all the columns, and I've run this. And then remaining data is taken into test. What was the logic? Ideally, there are different logics, but none of the logics hold true here because we have limited data. I've taken 80% into training and 20% into test. Okay. So here, this is the output variable confirmed. This is the output variable. So I'm running a linear model, y tilde t means y tilde t, and then I'm building this model on training data. I'm building a linear model. I stored the model here. When I do summary of this, I get to see the result. Okay, both of these are significant and all that p values. Then what I'm doing is I'm using this model to predict on the new data, which is a test data. So ideally here, the one thing that I'm trying to do is I'm trying to take this COVID data and then I split this into training and test. First step. Then on this training data, I built this linear model and stored here in this object. And using the model that I built, I'm testing on the test data. So for that, I'm saying predict using this model that you built on the test data and also come up with prediction interval. Okay, so interval because you cannot rely on a single number. Then all I'm doing is I'm calculating mean absolute percentage error. How do you calculate that? You say actual values. That is, you have this test data. Test dollar confirmed will have the actual values. So you're subtracting the actual values from the predicted values. Here you have the predicted values. When you subtract these two, you get error. Okay. If you divide that error, if you divide this error by your actual values, so error divided by actual values will give you percentage error, this percentage error. But then you're taking absolute value, which is called as absolute percentage error. Then you're taking a mean. That's mean absolute percentage error. We explain about all these error measures in finer detail as part of the training. Lack of time, so I'll run. So here the MAPE, mean absolute percentage error, is 55%. Huge error. No one would accept, no one would agree to this model. They'll say, hey, this is such a shabby model. Hence, we tried out exponential model. For exponential model, you take log of y, linear model of log of y tilde t. I've taken log of the output variable tilde t. Okay. And then I'm using training data. When we take the training data and then build a model, this is an exponential model and summary. Then what am I doing? I'm predicting using the model that I built on the test data. And I stored the data. Then I'm subtracting the actual data from predicted data. When you look at this, right, you will have fit, which is the predicted value. Since you want an interval, you get the lower range and upper range. But these values that you got are log values. Why are they log values? Because you have taken log of y. How do you get back the original values? Just take exponential of that. So we are taking exponential of the values. Dollar fit means it would refer to this column. Okay, so you actual value minus predicted value, which will give you error. Then you're dividing that by this part you get. Then you're dividing it by the actual. So you get percentage error and taking an average of that. That's mean absolute percentage error for exponential model. In this model, you got 55%. In this model, you got 41% or 42 if you wish to round it off. Let me try out quadratic model. Quadratic model means y tilde. This is how you write it. Linear model of y tilde x plus x square. And then you build the model on the training data. Summary, right? And then you take this model that you built, predict on the test data, construct prediction interval. Then once again the same thing, take actual value minus predicted value. When you subtract these two, you get error. Divided by the actual value, you get percentage error. Take absolute value of that, absolute percentage error, take mean of that. You get mean absolute percentage error. 50%, 50%, 41%, or 42 rather, and 55. Which one is the best until now, friends? Which model is the best until now? Quadratic or exponential or linear? Which one is better? Exponential until now. That has given you the least error, 41.9% approximately. Perfect. Thank you for paying attention, friends. Really motivates me. All right. Next, I'm assuming that there is linear trend and daily seasonality in your data. So I do this linear model of y tilde t plus sine and cos, as I've told you, captures what? Seasonality. T captures trend. Right? Seasonality means nothing. Up, down, regular up, down pattern. Right? And then I'm saying data equal to train. And we use sine and cos once again. I repeat, when you have daily seasonality. If you're taking daily data, then you need to use sine or cos. Okay. All right. Summary of this would give you the result. Then I take the model that I built. I'm predicting that on the new data, test data, and I'm constructing prediction interval. If you do this, you get to see the results. Now what I'm doing is I'm taking the actual value minus predicted value error divided by actual value, you get percentage error, absolute value, mean percentage, absolute percentage error. Then if you take mean of that, it is mean absolute percentage error. Take it, store it. 39. Which one is better until now? Which model is better, friends? Linear trend with daily seasonality is the best until now. Right? Absolutely. So we should have mathematics. Yeah, some mathematic knowledge is needed, Narendra. Sorry, I'm just quickly looking at it. Can we use Python? That's what Somit says. Yes, Somit. We can use Python. And is it easy to use in Python? Who told it is easy? No. See, friends, Vijay, don't get mistaken here. R was introduced to the world as statistical programming language. Okay. Python was introduced to the world as scripting language. It was used to build various applications. Now that data science started picking up, Python started finding its place. A lot of mature when it comes to your shallow machine learning algorithms and forecasting, they are very robust in R. A lot of deep learning algorithms are very famous in Python. So there is thin line of difference. Okay, if you have static data sets and structured data sets, go with R. If you have unstructured data such as images, videos, audio files, textual data, then Python is good. Okay, very important. Even when I interview people, I ask this question on what is the difference between R and Python. When do you prefer R? When do you prefer Python? Okay, so you guys should be able to demonstrate such knowledge. Okay, next, can we use Keras in TensorFlow? What do you mean by can I use Keras in TensorFlow? Okay, Samit, Keras is called as a high-level programming language. Okay, and TensorFlow is a low-level programming language. All right, there is a difference between these two, but can you run Keras on top of TensorFlow? Oh yes, that is exactly what the world does. Right, that is exactly what the world is doing now. If that's your question, that's my answer. Okay, Pile as a question. You need to go. Yep, absolutely. Why MAPE? MAPE is untouched by the units. Pile. It does. Units do not influence your MAPE measure, mean absolute percentage error. Hence, we are going with that. Let me ask. Language based. I mean, R and Python. So both require C. No, not at all. What is C? What is C++? They are gone. You don't need both of these. I am a computer grad. I've learned these. These are object oriented programming languages. To some extent, it's good if you know, right? But those have no correlation with R or Python. R, Python can be learned as a standalone programming languages, Narendra. All right, let's go on. Let's move on. If I assume that there is exponential trend and daily seasonality, for exponential trend, I told you that you need to take log of y, log of your output variable. Okay, log of y, and daily seasonality is captured using sine and cos. So I'm building this. I stored using assignment operator in this. Here is a summary. Okay, now I'm going to predict using the model that I built on the test data. And let us do this. Actual value minus predicted value will give you error, divided by actual value will give you percentage error. Take absolute percentage error. It's 146% roughly. Multiply it with 100, you'll get in percentage. It's very, very high. And remember one more thing, R squared value has no correlation with this error. Right? In forecasting, you should not be focused upon R squared or just R squared values. Or neither do we focus on the p values when it comes to forecasting. Okay, now what I'm going to do is I'm going to build a final model y tilde t linear trend plus daily seasonality sine and cos plus I'm also including something called as lag. Here I'm saying that the previous day cases will also help me determine tomorrow's cases. So today's cases will help me determine tomorrow's case, number of cases. That's the assumption which I'm going after with, going ahead with, and I'm building a model summary. Okay, and I'm predicting using the model that I built on the new data, which is test data, and I want a prediction interval. Then I take the actual value minus predicted value. What would that give you? That would give you error. So actual minus predicted or forecasted value. This part will give you error. If you divide this error by the actual value, this part will give you percentage error. If you take absolute of that, it will give you absolute percentage error. And if you take mean of that, mean absolute percentage error. Okay, I've run this. Then if I run this, look at that. 2.3% error. 2.3% is the error, friends, which is minuscule. So now all these errors I'm combining and creating a data frame. Then I'm giving column names. Now if I say view that table, you all this root, not MAPE, mean absolute percentage error. Here we go. And you know for a fact that this model is giving you the least error possible. So what did we just do? We applied a lot of forecasting models and we compared those models using what? Using mean absolute percentage error, and we have picked up that model which gives the least error. And do what? Finally, you need to implement the model. You split the data here into training and test, built your model using training data, and tested on the test data to calculate errors. Once you find that a specific model is giving you the least error, then we need to combine the data. We need to take the complete data. We took only 56 observations training, right, to build the model. Now I'm going to take all the 69 observations and build that final model. Which model gave you the least error? This model, right? This model. Confirmed y tilde t plus lag plus sine cos, this one. So I'm combining the entire data and building one final model and coming up with confidence interval with 95%. Here is a summary of the final model. R squared, adjusted R squared have reached the pinnacle, right? Now, in order to predict for the new data, all we need to do is go to, or you need to create a sheet. In this, you need to add new data. You have data until 30th March. So I've taken 31st March. I need to predict number of cases. Lag confirmed is the previous is until 69 you add. So the next one will be 70. And then I calculated sine and cos based on this. That's it. I'm supplying this model. So I'll help you guys choose this new model here. Let me do that. Life sciences healthcare, the new data. View the new data. Yeah. 31st March, what will be the number of cases? Let's see. So predict using the final model that you built on the new data. Okay, how many cases are we expecting, friends? Anywhere in the range of 852,000 to 869,000. Will it hold true? I don't know. We need to wait until end of business today and then check tomorrow. Tomorrow, let's check this and see whether we are going to meet this or not. And trust me, friends, with this limited data, there is only so much that you can do. Of course, we can build a lot of econometric models. One of our friend is asking, Piyush is asking, what factors will be taken to determine the spread of the virus? Piyush, there are a lot of factors. Our friends, we do life sciences healthcare analytics trainings, right? Doctors, a few of the doctors are working on the data which is given to us by Apollo, right? Probably we need to wait until they come up with some results to tell you on what all is impacting, but I can quickly show you something on life sciences healthcare analytics if I were, right? So not sure whether I can show this thing, but that's okay. Let me show. So this is a group shared some document. I can open that and show you. Right. So they have done some calculations using beta, gamma, and all of those. But I haven't seriously gone through this. I need to go through. But since this is directly coming from the doctors, I'm sensing that there'll be some merit in what they've done. All right, friends. So let's wait until tomorrow. Let's see whether we'll be accurate or not to the results. But it's very difficult to be accurate given that we only have 69 observations. But a true data scientist is a person who does some good given the constraints. Now, if someone gives me 1 year data building a model, anyone can do that. Given the constraints of limited data, etc., how can we do the best? That's what this is all about. Can we take recovered count as one attribute? Not sure. How would that determine number of cases, Sharat? I don't think so. If you ask me personally, I don't think so. Given my domain knowledge and experience, I don't think so. But maybe you might want to try out. The one thing is experiment, 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 and experiment. Right? We are not sure where you're going to, get gold.